activity again, Yuri.
That's just luck.
Yeah!
Notebooks and pens are landing on the runway, where memories served on the cafeteria tray. You and I together chasing dreams in the hallway. School bell rings and it's another day. Hey! Knowledge and truth is a hope that they can take away. We're flying, level up together forever without delay. So let's start today and everything's gonna be okay. Let's start today and everything's gonna be okay.
I've got a foolproof strategy of winning the game.
Now that's what you call strategy.
Hey, how'd you do that?
Simple. I just followed the method. I just observed your technique, avoided it, and from there, formulated my strategy.
That's right, Christine. What you just did to win the game is a perfect example of scientific method.
Really, miss?
Yes. And asking questions is a part of scientific method. You know, we can actually apply scientific method in our daily life without even being aware of it. But the good thing about it is that we can learn it and master it so we can apply it in whatever situation of our everyday. Want to know more?
Yeah.
Well, I think Dr. Bia is just about ready to take you through the scientific method with a good new experiment. Are you guys game to learn?
Game to learn!
Hi students, I have here with me a bag of marshmallows. This bag weighs 40 grams. What things might you want to know about this bag of marshmallows?
I would like to know how many marshmallows are there inside the bag.
I would like to know what colors of marshmallows are there in the bag.
I would like to know how many marshmallows of each color each bag contains.
Let us choose Lorenzo's question. Would you like to make a guess as to how many marshmallows are there in the bag?
I think there are 20 marshmallows inside the bag.
I think there are 18.
I think there are 23 marshmallows.
What was your basis for making your guess?
By looking at the size of the bag and based on previous experience, I have seen how big one marshmallow is, so I can predict more or less how many marshmallows are there in the bag.
How would we know if which of your guess is correct, if any?
We have to open the bag and count the number of marshmallows inside.
Now, count the number of marshmallows the bag contains.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23.
My guess is correct.
Okay, let us continue with this activity. I will give each one of you a bag of marshmallows. Count the number of marshmallows in your bag. Also determine the number of marshmallows of each color in your bag. Then, we will tabulate the results of your observations.
I have 8 green marshmallows, 4 yellow marshmallows, 9 orange marshmallows, and 4 pink marshmallows.
I have 9 green marshmallows, 6 yellow marshmallows, 4 orange marshmallows, and 5 pink marshmallows.
I have 9 green marshmallows, 4 yellow, 8 orange, and 5 pink marshmallows.
Okay, let us now graph your results. Your graph shows that the average number of green marshmallows in the 3 bags is 9, yellow 7, orange 5, and pink 4. The average number of marshmallows in the 3 bags, therefore, is 25. Look at this bigger bag of marshmallows. This bag weighs 200 grams. Using your data, what can you tell me about this 200-gram bag of marshmallows?
Based on the data we have obtained, the average number of marshmallows in the 40-gram bag is 25. Then, more or less, the 200-gram bag contains 125 marshmallows.
What we just did was an exercise in the use of scientific method for making inquiries. Biology as a science uses the scientific method for making observations for searching answers to questions about specific events. To summarize, herewith are the steps of the scientific method. First is making observations. A while ago, I showed to you a bag of marshmallows. You looked at the bag, made observations, and you asked some questions. You asked, how many marshmallows are there inside the bag? Second is formulating question. After you have stated your questions, you made guesses as to the number of marshmallows inside the bag. You were in fact stating your hypothesis. Third is stating a hypothesis. A hypothesis is an educated guess or a tentative answer to your question. Sometimes, a hypothesis is formed in a flash of insight, or sometimes after a long, hard thought. In our activity, what did you do so that you will know if any of your hypothesis was correct?
We opened the bags and counted the number of marshmallows in one bag.
The fourth step, therefore, in the scientific method is to test your hypothesis by performing an activity. When you found out that the number of marshmallows inside your bags were not the same, what did you do?
We computed for the average number of marshmallows in the 3 bags.
What you did was correct. Number 5, gathering and organizing data. Number 6, analyzing data. Based on your results, can you now make a conclusion?
Based on our results, we can conclude that the average number of marshmallows in the 40-gram bag is 25.
Very good, Alfonso. The 7th step in the scientific method is to make a conclusion based on the results analyzed. However, it is always advisable to have more samples so that your conclusion can be representative of the population being sampled. And number 8, reporting methods, your results, and conclusion. In real scientific researches, results should be published so that other people will learn from this new knowledge. A scientific investigation is always open for further study and research. In this way, scientific knowledge gained through scientific investigation is further strengthened and verified. I would like to emphasize that the scientific method is not only used by highly trained scientists. Anyone trying to solve a problem can use this. For example, it's nighttime and you're in a hurry to finish your assignment, but suddenly there's brownout. What would you do?
I will get hold of my battery-operated emergency lamp.
What if as you turn on your lamp, no light comes out? What would you do?
I would immediately guess the battery is dead, after which I would replace the old batteries with a new set.
Now, you ask your parents for a new set of batteries. But as you replace them in your emergency lamp, still, the lamp won't work. What comes to your mind?
Ma'am, maybe Ashley would think that the lamp was broken or it has loose connections. Then she would think that she would check the batteries first. Then when she placed the batteries in the flashlight would work. Then she'd figure out that the batteries were not dead after all.
Wait, maybe Ashley would think that she did not put the batteries in the right order and she would check it.
Okay, those thoughts may enter Ashley's mind. So she placed the batteries again inside the lamp and made sure that they were placed properly. This time, the lamp worked. In the process of responding to the problem of how to have light, Ashley thought of several reasons why her lamp would work. She was, in fact, stating several hypotheses. Then, she did ways to test her hypothesis. She checked if the batteries were dead using a flashlight. When she found out that the batteries were not dead, she again checked if the batteries were placed in the lamp correctly. She performed these trials until she was able to make her lamp work. Ashley was using the scientific method.
Ma'am, when I get a low score in the test, I ask myself, what was wrong? Why did I get a low score? Then I try to identify the causes, after which I devise a way to improve my methods of studying. That way, I could get a high score. I think that in doing so, I am applying the scientific process.
You are right, Lorenzo. Using your observations and analyzing possible causes so that you can come up with better means to address your problem is using the scientific method.
My father is using both organic and inorganic fertilizer to grow vegetables in our farm. He is testing which type of fertilizer would make plants grow better. I think he is using the scientific process.
Sometimes, my mom would compare which laundry soap could wash more clothes so that she could decide which brand to use. She did this several times to see if she could get the same results every time. I think she's also using the scientific process.
When my Lola tries different ingredients to make her vegetable soup more delicious, she does trial and error until she gets the taste she thinks is best. I think she is using the scientific process too.
On a greater scale, it was man's observation of flying birds that paved the way for the construction of the airplanes. The observations made about birds laid the groundwork for the airplanes to materialize.
You're all correct. The scientific method is something that we use all the time. In fact, engaging in basic activities that make up the scientific method, such as being curious, asking questions, and seeking answers, is a natural part of being human.
What about scientists? Are they a special group of people?
Just like you, scientists are real people. They have aspirations, dreams, fears, and sometimes they commit mistakes. But they are very curious, observant, patient, hardworking, and persevering. They are lifelong learners. They continue to develop their skills. In fact, they won't stop until they find the right answers to their questions. It is because of these traits that scientists are able to make contributions to society. Did you know that Thomas Edison used more than 6,000 kinds of plants to find the best filament that would make the bulb glow brightly and long-lasting? After conducting more than 9,000 experiments on the different kinds of filaments, he discovered that the carbonized bamboo filament glowed best. One day, a young reporter asked if he felt like a failure after more than 9,000 failed attempts, and if he thought he should just give up. Edison replied, "Young man, why would I feel like a failure? And why would I ever give up? Now I know definitely over 9,000 ways that an electric light bulb will not work. Success is almost in my grasp." After over 10,000 attempts, Edison produced a light bulb which is reliable, long-lasting, and would last up to 1,200 hours. The first bulbs lasted only for 150 hours. Did you also know that the discovery of the drug penicillin was due to an error in an experiment? Bacteriologist Alexander Fleming committed a mistake in his experiment when his bacterial culture became contaminated with molds. But before throwing out the contaminated culture, he noticed that the bacteria did not grow in areas where the molds were growing. The molds that contaminated the bacterial culture was penicillium. Fleming found out that penicillium releases a substance that kills the bacteria. This was how the drug penicillin was discovered. Today, penicillin is still considered as one of the most important life-saving drugs in the world because it can treat a wide array of bacterial infections. Had Fleming been a perfect microbiologist, he could not have committed a mistake in his contaminated cultures. Had he been less observant, he could not have noticed that the bacteria did not grow in areas where the molds were growing. He could have just thrown the contaminated culture dish in the bin and considered it an error in his procedures. But because he was very observant, he asked, why did the bacteria not grow in areas where the molds were growing? This problem was the beginning of antibiotic therapy for bacterial diseases. Science is fun. With continued practice, the use of the scientific method will enable us to become critical and analytical thinkers and can even pave the way for us to make significant contributions to society. Bye, Teacher Abby. Bye, Kay Havers.
Bye!
So, from what we learned from Dr. Bio, we can now say that the scientific method is the most basic procedure when we want to come up with proven scientific conclusions. As we strive to learn and discover more and more about science, we will always go back to this method. Now, to make sure that you guys have learned, I want you to enumerate the 8 steps in the scientific method. Okay. I asked you what the 8 steps in the scientific method are. So, can you name them all?
The first step is making observations. Like, I am smarter than Christine.
The second step is formulating questions like, why does Yuri think that he's smarter than me?
The third is stating a hypothesis, like, I'm smarter than Christine because I know more strategies in video games.
The fourth step is testing the hypothesis or experimentation. And it's clear that from the game that we played earlier, that I beat Yuri, that I'm definitely smarter than him.
The fifth is gathering all data. Of all days I played with Christine, this is the only day she won.
The sixth is analyzing the data. I may have lost all the other games, but today it is a significant win.
The seventh is making conclusions. And I, therefore, conclude that I'm smarter than Christine because even if she won today, I have won all the other times.
And the eighth and final step is reporting the methods, results, and conclusion. So why don't you go and report that conclusion, Yuri, and let's see if anyone believes you.
You guys are like cats and dogs. That's so hilarious. But what's important is that you get the scientific method. And with that, everything you do can lead to something that results to a greater learning.
And as we use the scientific method, we become more and more knowledgeable of whatever field in science we may choose.
That's right. It's just putting into definition what we already practiced on a regular basis.
And now that we know, we can be better at what we do and in all of our goals from now on. And my new goal is to beat Yuri.
You can try, but you won't succeed. Not if I can help it.
I won today, didn't I? So I'll keep winning.
Nothing like good, healthy competition. That's all right. But that's just the beginning. What's important is that in every scientific method, intellectual honesty and scientific integrity are present at all times.
Fairness and honesty.
That's right. So much more fun and exciting learnings to come. I'll see you here again at K-Hub.